This video reviews the combined gas law. The combined gas law combines Gay-Lussac's law, Charles's law, and Boyle's law into one. If you're given any 5 of the variables, you can solve for the 6th. So we're just adding a level of depth to what we've been learning by smashing together 3 of the gas laws that we've learned. Something to think about: why do we need the combined law, and what new situation does it address? Well, it addresses a situation where pressure, volume, and temperature are changing. We don't have a gas law that we've learned yet that allows us to solve a problem where all 3 of these are changing. So far, we've only seen problems where 2 of these measurements are changing and the other is held constant. So you use the combined gas law when you're given a problem that has pressure, volume, and temperature all changing, and there's no indication that something is held constant. So here's our first example. We're going to go ahead and start plugging in our values here. So we have pressure 1 is 300 torr. Volume 1 is 40 liters. Temperature 1 is 250 Kelvin equals, and then pressure 2 is 900 torr. Volume 2 is 10 liters. And temperature 2 is what we do not know. So we're solving for temperature 2. So to solve this problem, we're going to just algebraically solve it. Quick way to do this is using cross multiplication. So you would just multiply this times this. And you want to keep all of your units so that you can tell what you need to cancel. So 300 torr times 40 liters times T2 equals 250 Kelvin times 900 torr times 10 liters. And then to get T2 by itself, we want to divide by everything that's stuck to it by multiplication. So we're going to divide by the 300 torr and the 40 liters. That allows us to cancel both of those on this side. But we do everything that we do on one side of the equation to the other side also. So we have to divide by the 300 torr over here and by the 40 liters over here. So now this is where we're actually going to do some math and simplify things. So first of all, we can cancel our units that we have in both the numerator and the denominator. So we have liters we can cancel, liters we cancel, torr and torr we cancel. That tells us that the units on our answer are going to be Kelvin. And that's what we want because we're solving for temperature. So this is why we keep our units written throughout solving the equation so that we see that we've set up the question correct and we are given the units that we want at the end. So now we can keep solving. So I'm going to cross off some zeros here because there's a lot of them, and if we have zeros on both the numerator and the denominator, we can cancel. So this 10, I'm going to cancel this 0 here with this 0 down here. I'm going to cancel 2 of these zeros here with these 2 here. So now all I have is 250 times 9 divided by 12, because 3 times 4 is 12. So let's rewrite it. So we have 250 times 9 divided by 12. And we know that our answer is going to be in Kelvin, so we can leave the K out there, and this is going to be T2. We're running out of room here. And our answer is 187. So I'm just going to write it over here. 187.5 Kelvin is T2 because I ran out of room. There's our answer. Here's example 2. A Cheetos bag is sitting in a car at STP, that's standard temperature and pressure, and has a volume of 0.5 liters. Then the car is heated to 27 degrees Celsius. The pressure increases to 1.2 atmospheres. What's the bag's new volume? There's a lot of information here. So let's go ahead and pull all that information out. So first, Cheetos bag sitting in a car at STP. STP means 273 Kelvin is the temperature. That's so the T1. And the pressure is 1 atmosphere. That is what standard temperature and pressure mean. So 273 Kelvin and 1 atmosphere. And we're given our volume, so here's V1, 0.5 liters. Then the car is heated to 27 degrees Celsius. Okay, this is screaming for a conversion. We cannot use Celsius. So we need to convert this. K equals degrees Celsius plus 273. We plug in our degrees Celsius here. We add 273. We get 300 Kelvin. Okay, so 300 Kelvin is our T2. We're going to just make some room here. Okay, 300 Kelvin is our T2. So we'll just fill this in. T2 equals 300 Kelvin. Okay, the pressure increases to 1.2 atmospheres. That's P2. What's the new volume? V2 is what we're solving for. So now we can set up our equation with all these numbers. It's a lot of numbers. So pressure 1, 1 atmosphere. Volume 1, half of a liter. Temperature 1, 273 Kelvin. Pressure 2, 1.2 atmospheres. Volume 2 is what we don't know. Temperature 2 is 300 Kelvin. Okay, so now we're going to solve it. In this problem, we have volume 2 is in the numerator, so that we could solve this a little bit faster by multiplying by the reciprocal of what is stuck to volume 2. Why don't we do that? Please don't be confused by this. So this is just another way of it's doing basically the same thing as cross multiplying. It's just going to take up less space on our paper. So all we're going to do is multiply by the reciprocal of this on both sides. So basically that looks like this. We're doing 1.2. Oh, I did that backwards. So 300K, so when we say reciprocal, we mean like opposite or upside down. So we multiply by that on this side, and that's going to cancel. So we're left with V2. But then we have to multiply by the same thing here on the other side. And we don't have very much room over here, so let's see. We're going to we'll just rewrite it. So 300 Kelvin times 1.2 atmospheres. We're just going to make a giant fraction. So now we're just rewriting what was already there. 1 atmosphere, half a liter, 273 Kelvin. Okay, and this all equals volume 2. So now we can cancel things. We can cancel atmospheres. We can cancel Kelvin. That's awesome because we want the units on our answer to be liters, and that's what we're left with. And now we're going to just multiply and then divide this out. So we're going to do 300 times 1, which is still 300, times 0.5. Which you guys know is the same thing as dividing by 2. So now we have 150 on the numerator, and then we divide that by 1.2 times 273. So we know that we'll rewrite it. We have 150 in the numerator, and then we have, let's see what 1.2 times 273 is. 1.2 times 273 is 327.6. So now we're going to simplify this. 150 divided by 327.6. And we got 0.46 liters is our volume 2. Last problem. If a gas at 6 liters and 30 torr is compressed to a pressure of 600 torr, what is the new volume of gas? Okay, we're looking at this problem, and we have liters, volume 1. 30 torr, that's pressure 1. It's compressed to a pressure of 600 torr, pressure 2. What is the new volume of the gas? V2. This example does not give us any temperature. There is no information about temperature. We can assume that temperature does not change. So we're not going to use temperature here. We're just going to use Boyle's law. So I hope you see that if you cross off temperature here, you just have Boyle's law. You already know that one. So this is sort of a trick. So 30 torr times 6 liters equals 600 torr, and we're looking for volume 2. We divide by what is stuck to volume 2. That, I swear, says torr. Divide by 600 on both sides of the equal sign. Then we get to cancel. That cancels because 600 divided by 600 is 1, and torr divided by torr is nothing. Cancel torrs over here. So now we have 30 times 6 divided by 600. 30 times 6 is 180 divided by 600. 0.3 liters is our volume 2. And this lesson is done.